Okay, take a look at this. This is what we gotta find now. Okay. So, earlier we saw that this is 0 over 0. We can use L'Hopital's rule. And what is that? Well, it's basically just differentiating both the top and the bottom with respect to this variable right here. So, since this is a limit approaching 0, I'm going to notate this as just lowercase l. It looks too much like an e. I'm going to notate this as lowercase l. Okay, so all we're really doing right now is taking the derivative of both the top and the bottom. I'm not going to write it out. It's going to take way too long. Okay, so this is going to have to take it slow and steady, work through it term by term. Let's go through the top first. So the top, first of all, you can notice that this pi is a constant, right? So it's going to stay on the outside. So all we're really doing is taking the derivative of this function in here. And, well, it's t times this exponential. So in actuality, what we're using is the product rule, right? Okay, so let's differentiate with respect to t first and then keep this guy the same, right? It's just the derivative of this times that plus the derivative of this times that. So let's take the derivative of t first. That's pretty simple. That's just 1. And we're multiplying it by this guy without touching it, right? E to the 2 pi t. All that gives us is just e to the 2 pi t. Next, we're adding on, take the derivative with respect to e to the 2 pi t now, right? So what that does is the chain rule says, well, the derivative of the top, we have to multiply that onto the side, and that's just 2 pi. Okay, and the exponential is going to repeat itself because that's how all exponentials work. Don't forget, however, that we're keeping this t here. So I'm going to insert it in the middle. Like that. Okay. Next, this right here, notice that this, the derivative of pi t is just pi. Okay, right here, the minus sign is going to stay. The derivative of this guy is just 2 pi e to the 2 pi t, right? Because of chain rule, once again, right? The exponential is going to repeat, and then we want to take the derivative of the top, multiply it on this side. Finally, the 1 is going to go to 0 after we take the derivative. Okay, so that's the top sorted out. Now what about the bottom? Well, the bottom, it's also product rule, right? There's this times that. So let's take the derivative with respect to this guy first, right? So what that really gives us is, well, power rule. T squared, that's just 2t, right? So 2 times 2t times all that. 2 times 2, of course, is going to give us 4. We're going to have the t sitting by itself. And then this guy right here is going to repeat. Okay, and then we add on. Now, instead of taking the derivative of this right here, we now take the derivative of this right here. But this guy repeats, okay. So let's go ahead and actually just write down the repeat first. Now let's take the derivative of this. So the derivative of -1 goes to 0. So we can just go ahead and ignore the last term. We're really just working with this guy right here. The derivative of e to the 2 pi t, as we saw earlier, is just 2 pi e to the whatever. And I'm going to go ahead and multiply the constants together. 2 times 2 is 4. So we really have 4 pi, and then t squared, and then your exponential. 4 pi t squared, and then your exponential e to the 2 pi t. And right now, that looks good as far as I can tell. Yeah. Let's just go ahead and expand this out a little. So the top, I'm going to go ahead and distribute in the pi. Pi e to the 2 pi t plus 2. Now this becomes a pi squared, right? Because pi times pi. The t stays, and then e to the 2 pi t. And then all the other crap on top stays the same. Okay, next, divide it by, and I forgot, we need this limit. Okay. On the bottom, I'm going to just multiply in, I'm going to multiply in this 4. Yeah. So 4t. So this just gives us 4t times this first term right here, e to the 2 pi t, minus 4t times 1 is just 4t. And then this next term right here stays equivalent. Okay, so any other way we can simplify this? Well, notice that all of these terms, this one, this one, this one, and this one, they all have a pi. So we can factor that out. We can bring it outside the limit. And then all these have 4s, right? So we can bring a pi out from the top and then a 4 down out the bottom. Limit. So now all these are going to be missing 1 pi. So this pi squared just becomes pi again. E to the 2 pi t plus, well, this pi got moved outside, so now it's just 1. And then minus 2, we also got rid of that pi, e to the 2 pi t. The bottom, we just got rid of all the 4s, right? We could have also factored out the t, but I'm working with constants right now, so I'm not going to be touching the t too much. Yeah, all we get is all of these terms again, but no more 4. Okay, so that's it. But if you go ahead and plug in 0 again, right? This is the limit as t approaches 0. This right here, you get 1. This right here, this t is just 0, right? So 0 times anything is 0, so this becomes 0. This becomes plus 1, and then minus, plug in a 0 up top here. This exponential guy just becomes 1, right? 2 times 1 is just 2. Okay. Okay. You can also combine like terms, actually. So I'm going to do that in a second. But in the bottom, there's a t here, there's a t here, there's a t here. All we really have is just 0 minus 0 plus 0. So once again, notice that you have 0 over 0. What does that mean? You can use L'Hopital's rule again. And it looks pretty complicated right now, but it's going to start. Well, it's not even going to start getting tamer. It's just we're going to keep using L'Hopital's rule until eventually we might have something that we'll be able to work with. All right. Okay, so I'm currently rewriting everything that we have down here, right? So this whole line right here, up here. And I just wanted to point out that this and that, these are like terms. So one of these guys times minus 2 of these guys just gives you negative 1 of them. So I just went ahead and wrote in a negative sign up there. Other than that, everything else is the same, right? I just moved this pi over 4 inside the limit, but either way, it's the same value. So yeah, but we can actually keep working now. And as I said earlier, we're going to be using L'Hopital's rule again. Basically, differentiate with the top and the bottom. Okay, and this iteration is where it gets a little bit crispy because, you know, there's a lot of stuff. But yeah, okay. So, let's rewrite the limit. And then we have our pi over 4. And we're going to take the derivative of the top and then the derivative of the bottom, right? So let's take the derivative of the top. Let's look at this first term here. The 2 pi is a constant, so it's going to stay on the outside. And inside here, you're going to use product rule. So just like earlier, now we have t times e to the 2 pi t. Let's just take the derivative with respect of this right here first, right? And that's going to give us 1, so this, we just have 1 times the other guy. Okay, now let's put down this 2 pi again, because it's constant. Now, let's take the derivative with respect to this guy, right? And then the t is going to repeat. So let's let the t repeat first, actually. The derivative of this, well, it's an exponential. So the exponential itself is going to repeat. And then you're going to take the derivative of the exponent and multiply onto the side. And that's just 2 pi. So 2 pi times 2 pi is just 4 pi squared. So let's put it down like that. So that's the first term taken care of. Now let's move on to this next term right here, right? This is just a normal exponential, nothing too much. So all we're going to do is, by chain rule, we take the 2 pi down to the side, and then this exponential e to the 2 pi t. Okay, and that's it for the top, because this derivative of 1 is just 0. All right, next, let's take the derivative of the bottom. Right here, the pi t squared, e to the 2 pi t. Pi is just a constant, so we're going to have that repeat. We're going to keep that on the outside. And this is, once again, a product, right? So let's take the derivative of this guy first. The derivative of that is just 2t. So we have 2t, and I'm going to write in the pi again, right? And then this other guy here is going to repeat. So e to the 2 pi t. Okay, add. We're going to have the t come in again, because that's a constant, remember. The t squared is going to repeat. And then we're going to take the derivative of this guy now, e to the 2 pi t. So e to the 2 pi t, that's going to repeat because it's an exponential, but we're going to take the derivative of the top, right, of the exponent, and then multiply it on. The derivative of 2 pi t is just 2 pi. 2 pi times this whole thing is just, well, 2 pi squared, right, because you already have this pi. So 2 pi squared. Okay, next. This guy. This is once again product rule, but now we don't have a constant on the outside. So let's take the derivative of t first. The derivative of t is just 1, and then the other guy is going to repeat. So e to the 2 pi t. Next, we add on the derivative of the other guy with this first one repeating. So let's put down the t. That's going to repeat, right? We're taking the derivative of this exponential. The exponential itself is going to repeat just like any other exponential, but you have to use chain rule. The derivative of 2 pi t is just 2 pi. So we're going to have a 2 pi multiplied onto the outside. Finally, we're dealing with this last term. The derivative of negative t is just negative 1. Okay. So, yeah, it's not prettier, but I'm going to tell you that it will eventually end up working. Let's check that I still have everything correct. Right, okay. So, really cool thing that happens on top, you might be able to see it, there's actually cancellation, right? So, this is positive 2 pi e to the 2 pi t. This is negative 2 pi e to the 2 pi t. So, all you're really left with on top is this. Now, you notice that there's a 4 on top and there's a 4 on the bottom. This guy and this guy, they can cancel. Okay, so let's go ahead and move this pi. Now the pi is just... Well, actually, it isn't. Let's go ahead and write down the next line, because something pretty cool happens. And are there any like terms down here? Yeah. So we have this guy right here is a like term with this guy. All right, so let's just summarize what we did. Let's move this pi to the outside because it's starting to look messy. And notice how we still have this pi squared on the inside here. We can also multiply that to the outside since it's just a constant. So on the outside, you have this pi and then this pi squared. Then it gives us pi cubed. We have the limit as t approaches 0, which I'm going to write as that again. These two, let me check if this is correct. Yeah, it is. So on the bottom, in fact, I'm going to just write this long guy first. 2 pi squared t squared e to the 2 pi t. Okay, next let's put down these two like terms. 2 pi of t e to the 2 pi t plus 2 pi of t e to the 2 pi t. It's just 2 of these guys, right? So we're just multiplying one of these guys by 2. That gives us 4 pi t e to the 2 pi t. So 4 pi t e to the 2 pi t. Okay, this exponential right here plus e to the 2 pi t. And then we just have this negative 1 sitting on the outside. On top here, notice that we already canceled these guys. We canceled the 4. We moved the pi square outside. So we're just left with whatever's in black, right? E to the 2 pi t. Whew. All right. So now we have it simplified down again. I need to make sure everything's still recording, actually. Okay. So if everything is simplified down again, we can't do any more simplification. If we plug in 0 for t, however, we notice that the top gives us 0, unfortunately. This first term down here, 0 times anything is just 0. 0, right, there's a t here, times anything is still 0, and then over here, e to the 0 gives you 1, but you still have this minus 1, they cancel, 0 over 0, unfortunately. So, use L'Hopital's rule for the third time. And hopefully, this actually ends up getting us somewhere, because right now it feels like, you're doing work for nothing. But, we'll see. We'll see. Okay, so let's do L'Hopital's rule again. So this pi cubed is going to stay out here. We have the limit as t approaches 0. We take the derivative of the top and the bottom. I'm going to go ahead and take the derivative of the bottom first, simply because it's longer, right? So we just want to get that over with. Okay. On the bottom, let's deal with this guy first. 2 pi squared, that is a constant. So we're going to have it just stay on the outside. This is a product again, right? T squared times e to the 2 pi t. Let's take the derivative of t squared first. That is just 2t, right? This 2 and this 2, they multiply and they make 4. So, and I'm going to squeeze this t in. And then this e to the 2 pi t repeats. Next, let's take the derivative of this guy. So once again, I'm going to write down the 2 pi squared again, because that's a constant. But then keep in mind that this t squared repeats, so I'm also going to write that down. And then we want to take the derivative of this guy, right? So because this is an exponential, it's going to repeat. But chain rule says you have to take the derivative of the top. The derivative of the top is just 2 pi. Multiply it onto the side. 2 pi times 2 pi squared is just 4 pi cubed. Alright? So that's the first term done. Now let's work on this one. So, here, 4 pi, right? That's our constant. We're going to keep that on the outside. And once again, just like the previous one, this is also a product. So let's take the derivative of that guy first. So, the derivative of t is just 1, right? So, and then we just have the other guy repeat. So, 4 pi e to the 2 pi t. Okay, now let's take the derivative with respect to this other guy right here, the exponential. Once again, I'm going to put down the 4 pi since it is a constant, and the t is also going to repeat since we're not taking the derivative with respect to that. Instead, we're doing it with respect to this. Since it's an exponential, the exponential is going to repeat e to the 2 pi t. But chain rule says we have to multiply by the derivative of the inside. The derivative inside is 2 pi. So 4 pi times 2 pi is 8 pi squared. Okay, so we've got this. Oh, all right. We just got one more term left to deal with since notice that the derivative of this is just 0. The derivative of that is just an exponential, right? So it's just 2 pi e to the 2 pi t for reasons that I've already done like probably dozens of times. 2 pi e to the 2 pi t. So I got this all to fit. This guy, why does it look like that? It's because it's an exponential, right? So the exponential part is going to repeat e to the 2 pi t. But you're going to chain rule, right? So that's the derivative of the top, multiply onto the side, just 2 pi. So that's the bottom, thank God. Now let's work on the top, right here. So the top is pretty simple, it's just one product, right? So let's take the derivative of this guy first, the t. So the derivative of t is just 1, right? So 1 times the other guy. Okay, add it on to. Now you want to take the derivative of this guy right here. And then have the t repeat, right? So let's do the chain rule first. 2 pi, right? That's the derivative of the inside. So I'm going to move that. I'm going to multiply that onto the side. Now let's have the t repeat. And then let's have the exponential repeat. That's just how you take a derivative. Okay, so that was the final derivative, hopefully, right? There's some simplifications that we can make. First of all, notice that there are some like terms on the bottom, right? So this guy, we can combine with this guy, right? They all have pi e to the 2 pi t. this pi squared right here, we can also combine with this pi squared, right? They all have pi squared t e to the 2 pi t. And I think that's it, right? There's not much else that we can combine in the bottom right here. So let's combine that first, and then we'll see where it leads us. So we still have this pi cubed, and we have this limit as t approaches 0, right? And then let's just write down the bottom first. So I'm going to put down this guy here first, because it's the longest. 4 pi cubed t squared e to the 2 pi t. And then let's combine some like terms. So let's do the squiggly guys first, right? 4 of these guys plus 8 of these guys is just 12 of these guys. So we have 12 pi squared t e to the 2 pi t. Okay. Then now let's combine these solid bar guys. 4 of these guys plus 2 of these guys is just 6 of these guys. So 6 pi e to the 2 pi t. And then, yeah, so that's it for the bottom. On top, this is going to repeat, right? There's no like terms or anything. But you can probably see some pretty cool cancellations about to go down. Because, well, now let's see what we can factor out of both the top and the bottom. So, on top, you can factor out e to the 2 pi t, right? So, I'm going to write this down again. Pi cubed, the limit as t approaches 0. On top, you factor out e to the 2 pi t, but there's not much else. On the bottom, though, there is a lot. 4, 12, and 6 are all divisible by 2. And in each of these terms, we actually always also have a pi. Pi cubed, pi squared, pi. We can factor out a pi out of that, right? And then we also have e to the 2 pi t in each of these terms. So, e to the 2 pi t. Now, before we go ahead and do cool cancellations and stuff, I'm going to go ahead and write this in again. So on the top, we factor out this guy, right? So this becomes a 1, and then this becomes, well, we factor out this guy, right? So it's going to just disappear. We just have 1 plus 2 pi t. In the bottom, it's a little more complicated, but it's fine, right? First of all, for each of these terms, you can just ignore the 2 pi t. I'm not going to keep saying that. So I'm just going to cross them out so we don't need to look at them. Now it looks a lot better, right? So we factor out a 2 pi from each of them. 2 pi, dividing this guy here by 2 pi, you get 2 pi squared, and then t squared. Next term, dividing this guy here by 2 pi gives you 6 pi t. So that's pretty simple, 6 pi t. All right, and then finally, this final guy right here, dividing 6 pi by 2 pi, the pi's are going to cancel. You're just going to be left with a 3. Finally, let's go ahead and cancel these, right? So that's gone. And let's move this 2 pi outside. Pi cubed over pi is just pi squared, and then you have this over 2. And you have the limit as t approaches 0, which we can finally evaluate, because notice that in here, this is not an indeterminate form anymore. 2 pi squared, t squared, plus 6 pi t plus 3.